All right. Good morning, good afternoon, whenever you're watching this. My name is Jonathan Rowe. I am the Southeast Business Development Manager for Evaptech. We just built your cooling tower. So today, I'm going to be sharing with you a PowerPoint presentation going over some operation and maintenance things to look out for on the tower, as well as taking you out to the tower and showing you a few things that you should be watching for as the tower is in operation and when the tower is offline. So for the agenda for the PowerPoint, what we're going to be doing is just going over a basic overview of Evaptech. We're going to be looking at different types of cooling towers. We're going to be looking at some of the recent cooling tower things that we've done to innovate on the build of the cooling tower, and which includes the structure, fill, fans, gearbox, etc. And then we're going to be talking specifically about the operation and maintenance of your cooling tower and some inspection things that you need to do monthly, quarterly, semi-annually, and yearly. And then we'll wrap up with any questions if you have any. Evaptech was started in 2005. Evaptech is actually the daughter company of Evapco, which is our parent company, that does mainly HVAC and refrigeration applications. So you can see Evapco HVAC systems on top of hotels, hospitals, scattered throughout the country, scattered throughout the world. They're headquartered, Evapco is headquartered in Tawnytown, Maryland, but Evaptech is headquartered in Edwardsville, Kansas. So we do everything from building the tower, servicing the tower, aftermarket. We do inspections, basically anything that you need as far as cooling towers, we can provide. And that's wet cooling towers. We have a sister company called Evap Dry that deals with the dry applications only. They do a lot of things with power plants that don't have access to water, and so everything is air cooled. So now we're going to talk about some cooling tower types. One of the main types that you're going to see deployed in the field are your counterflow cooling towers. Next, you have your crossflow cooling towers, which you have built here. You have your FM certified cooling towers, and that is a cooling tower type certified by FM Global that does not require a fire suppression system installed within the tower. And so your fill, your drift eliminators are different. The rest of the construction is typically FRP, and you have your stainless steel hardware. But it's really the PVC fill, which is called our Franklin fill, and the drift eliminators, the Franklin drift eliminators that are going to be different and specific to this tower. And then you have a mix, which is a counterflow tower, or a hybrid, which is a counterflow tower that has coils within it, which is going to mirror some of your HVAC systems. And that's usually what you see within a closed loop system. So some of the structural material that you have on your tower, it's basically FRP protruded members, which is different from your typical 2x4s or 2x6s and your 4x4s that you see on your the earlier built towers, which are like the redwood constructed towers. Evaptech or Evapco is a vertically integrated company. We do all our own FRP protrusion. And so everything that you see as far as the structure on your tower is going to be coming straight from us. And all of the protrusions are made to mimic essentially your solid wood members. So although you have your 4x4 FRP protruded structural member, which is going to be mimicking a 4x4 wood member, you have your C channels like usual, and then you have a fan deck, or your fan decking, which is going to have its spines that are there to support and have structural integrity for your fan deck. each member on the fan deck. And this is some of the enhancements that I was telling you that we were going to go over. Whenever you have a load bearing surface, between your structural member and a solid surface, you're going to have an insert. So what we do for the FRP protruded 4x4 members that's connected to your base, you're going to have a neoprene pad to evenly distribute the load that's coming through that 4x4 member. You also have stainless steel inserts for your bolting going through the members, and that's to prevent sliding and slipping and shearing that's going to happen as the tower's in operation over time. Also, whenever we do wood to FRP conversion, we do the same thing typically that you see from the FRP member down to the foundation, which is we insert a bearing plate to help evenly distribute the load between the 4x4 wood member and your hollow 4x4. And that, again, typically happens when we're talking about doing wood to FRP conversions. The fan deck, it's a typical fan deck that you're going to see on all your towers, but our fan deck, we try to maintain a surface for safety. So our Evaptech has textured surface, so you have better grip. So when you're going out there in the rain or some type of weather event that's going to have or cause water to be on the fan deck, maybe it's dew in the morning or something like that, that deck is going to have that textured surface to help prevent slipping. These are some of the fills that you will typically see in cooling towers. This is Evaptech's specific fill. In your tower, you have the arch bar, and that's going to be a splash type fill. It's for applications that are going to have a lot of solids in the water. You don't want your cooling tower. You don't want your cooling tower basically losing its ability to cool the water. And as the fill becomes fouled, it loses that ability to have water to surface contact, which decreases its ability to cool the water. Your TC312 or Tech Clean 312 is the third iteration of the Tech Clean fill that we have, usually placed within our Carniflow towers, and that has 12 millimeter or 12 sheets of fill per inch. So no, per foot, sorry. You have your Verticlean 16. That again is going to be placed within your counterflow cooling towers. And then our dry air drift eliminators is for drift rates that when you're trying to keep your drift lower than 0.001, which it can go up to 0.00001, so 0.0001. Cooling tower maintenance benefits. You want to make sure that you're constantly walking down your tower. You want to make sure that you're checking the oil. You want to make sure that you're looking within the fan stack, checking the fan blades. And this is typically done on a semi-annual basis to make sure that you're preventing your gearbox from losing oil, which is going to run it dry, which is ultimately going to wear it down, that you're going to have to replace it. And you're basically, it's like your car. You want to make sure you're servicing your cooling tower for the benefit of keeping it as long as it's able to function without having to constantly put money into your cooling tower. The structure has a little play in it because it's FRP, so it's going to last a long time. But you want to make sure that you're walking it down, making sure that your bolting is secure, tight. You don't see anything that's starting to pop out or creep out. You want to tighten down, go and touch it with your hand, see if you can spin it. If it's it's spinning, that means you need to tighten it down, or you need to replace the hardware, replace the bolting. The nozzle type that you're going to have on your counterfloor cooling tower is going to be a hot water basing nozzle, which is basically a gravity fed nozzle. It's not going to be something that's going to have power behind it, and that's going to be your, here's the typical. I think on your tower you have your spiral target, which is essentially this, and it's basically as the water drains through, it helps distribute the water, giving it a spray pattern, a wide spray pattern. That's going to be spaced out in 1 foot increments. As I was speaking to the Tech Clean 312 before, it's Evaptech's proprietary fill, and it's the 3rd iteration of the Tech Clean, which is what we deploy most out in the field. Has great thermal performance, low fouling, very durable, it lasts a long time, as well as it says CTI standard compliance. Most of what we do in Evaptech is CTI standard. There's only a few companies that follow CTI standards, and Evaptech is highly regarded as one of the standards within the cooling tower industry for performance, quality of the build, and maintaining safety and making sure the tower is built to last. You know, we tell you it's going to last 20 years. It'll last 20 years as long as you maintain a good operation and maintenance program. So your arch bar splash fill, again, this is what you have in your tower. So it's an open mesh design. You're going to have low flame spread. Since obviously it's an open design, it's not going to catch fire easily, and the flame's not going to spread if it does catch on fire. Increased efficiency, reduced maintenance costs. What to take away from this with the splash fill is that counterflow towers are made to handle very dirty water. So with the arch bar splash fill, it's open. It's not going to be damaged by things falling through the tower. If you have anything that's in your water that is like calcium buildup, high calcium content in your water, or something like that, it's not going to create an issue for the splat or for the fill. If you have cold weather events where there's freezing and there's a heavy load on that fill, it's not going to be damaged because of the structural integrity of the design with the arch. So that's one of the main benefits from the arch bar splash fill. So for maintenance purposes, whenever you're trying to get into the gearbox, it's great to have a FRP walkway and lily pad, but mainly a FRP walkway, so you're not, you can just not scaffold, but place down the grating that's there for you to access your gearbox, instead of having to use scaffolding placed inside the fan stack. It just makes servicing that gearbox easier. If there's issues with your fan hub, you can get out there and check the gearbox, check the coupling from the drive shaft to the gearbox, and fix any issues that you have, especially with changing out fan blades if you need to. So back in 2016, OSHA changed its requirements for the type of ladder system that you need to have on your on a cooling tower. So now what we employ is a ladder that you would hook up. You need to have a harness on when you're on top of there performing maintenance. And so as you descend, you have the lanyard, so that you're not just dropping down. Because if you have the cage, it was found out that the cage hinders the ability for a person to crawl down the ladder effectively, especially if he has on gear. So they did away with the cage, made it a requirement that The person can do a, your self-rescue. You hook your lanyard up. Your louvers help direct the airflow going into your tower. It's mainly what they're there to do. Help break up the airflow, make sure you have an even distribution, as well as prevent splash out. It keeps the water in the tower. And that's essentially what they're there to do. And as maybe you have a high wind day and you need to adjust the louvers, or, you have a low wind day, you need to open it up a little bit more. That's what adjustable louvers are there to allow you to do. So your vibration switch is going to essentially cut the fans if there's high vibration on the tower. And that is connected to your motor. So if the vibration in the motor is high, which means that there may be some misalignment between the motor and your gearbox. There may be something going on with your fans and your fan assembly, and it's going to translate or transfer all of that vibration back to your gearbox, and it's going to cause that vibration switch to say, hey, it's too much vibration going on. We need to shut it down before something becomes damaged beyond repair or inoperable. Also, you have your low oil level switch, which basically is connected to your gearbox to read the oil level within the gearbox. If your oil level is dropping, it shuts down the operation of the fans in your motor so that you don't burn your gearbox. Whenever you're doing your oil level checks on your gearbox within the fan stack, you want to make sure that the oil level is more than halfway on that sight glass that's on the gearbox, more than halfway above that nut, which you can see there. It's almost like if you divide it in half, you'd be able to tell just by eyeing it. Like, hey, oil level's low. Outside of the gearbox, you have another oil level indicator that's going to have two indicated levels on there, where one is full and the one below that is you need to add oil to it. When the gearbox or when the fan is off or the tower's off and it's not in operation, the oil level should read full. Again, just like your car, if you start it up, oil level is going to drop. You don't check the oil level when the tower is on. You check it on, it's off and it's cool. Give it a good 2 hours. Go and check the oil level. Hey, we need to fill it up. If it's below that need to fill line, or if it's in between full and need to fill, you're still good. So Amarillo, they have a service department called Amarillo Gear Services, where they take gearboxes that have been in operation, and what the site does is ship it to the facility, and Amarillo does an inspection on the gearboxes to say, hey, your gears or whatever is damaged, and you know what, we can repair it for you. They have 5 different tiers 1 through 5, and they can repair that gearbox as if it was brand new, send it right back out to you for a reduced cost. Instead of you buying a new gearbox, you can just renew a gearbox that you've already had and pay a cheaper rate. Whenever you're doing your oil change outs, and we'll take a look at what the recommended timeline for oil change outs are for your gearbox. But whenever you're doing your oil change outs on your gearbox, you either have a system where you just go in and you can pump it out like this mobile unit, or you have some other type of system where you can just hook it up. There's a pump on the bottom of the tower, and along with a feed, turn on a pump, change out your oil, and then you're good to go. Make sure it's topped off and oils have been changed. the beauty of the mobile oil, the gearbox service unit or the mobile unit is you can just move it from tower to tower. If you had a lot of cells, then it gets old. Changing out 10, 12, 20 cells of oil. But if you have two, you can do it however you want. I think it's easier to just, you don't need a mobile unit, but again, it saves time, makes it easier, instead of doing it the old-fashioned way where you just let it drain and then you go back in and fill it up. Fan brakes. You guys have a handbrake system. You don't have an automatic braking system, but this is just basically speaking to stopping the fan when you're coming off and you want to slow it down quickly. You don't stick a piece of wood in there and try to jam it up to stop it. You're gonna hurt yourself, you're gonna hurt somebody, or you're gonna break your drive shaft. Something's gonna happen that you don't want to happen. So make sure you're properly using the components of the system that's there to stop the operation of that fan. Either your emergency stop, you make sure you want to hit that. You communicate with your control room. Hey, stopping the fan. You use your handbrake. That's really the only way to stop the motor from spinning the fan blades if there's ever an emergency situation that you need to stop the fan. So some of the benefits of maintaining a good maintenance schedule on your tower is you want to make sure your equipment operates as designed, because you're trying to get the cold water, the coldest water that the tower can provide. You want to make sure that you maintain that tower, because over time there can be some drift in or difference between the hot water coming in and the cold water going out, which is going to impact how much power you can provide. You want to make sure that the water is evenly distributed within the cooling tower, so you want to make sure you're checking your hot water basin, your nozzles, make sure they're free and clear. Your drift eliminators, you want to make sure they're not clogged up, because if they get clogged up, you're not pulling enough air through your tower, which means that your fans are probably going to be working overtime, which means that's just going to affect your motors. You want to make sure your drive shafts have proper alignment, because it's going to increase vibration within your tower. Make sure you have your motor serviced. You want to make sure you have your gearbox serviced. You want to make sure that you're checking your fans. You want to make sure that you're checking your gearboxes. And again, maintain a good maintenance schedule on your tower to keep the life of the mechanical components, or maximizing the life of your mechanical components, because that's going to be where the wear and tear is going to happen on your tower. It's not going to be your structure, it's not going to be your fill or your drift eliminators. It's going to be the moving parts of your tower. Fan inspection. Whenever you open up or whenever you come down for an inspection on the tower, you want to open up that access door that's on that fan shroud. What you're going to do is you're going to hand spin the fan. It's always clockwise. It's always clockwise. Do not spin your fan counterclockwise. You're going to pick a spot and you're going to spin it. You're going to pick a spot on the fan shroud and you're going to spin it. And you're going to make sure that each fan hits that spot, fan or blade after blade. Because if one's off, then you're going to know that, hey, I need to correct this somehow, or something's wrong with this blade. If you have the capability, you want to make sure you check the angles on the fan blades, just to make sure that, as designed, it's pitched correctly, because that's impacting how much airflow you're having through your cells, which, again, it'll impact the cooling of the water that's going through the tower. You're going to check the leading edge, make sure that it's not being worn, and you can see some of the core of it, that the epoxy has been worn off, that's an indication that you either need to get it recoated or replace the fan blade. Check the clamps. Make sure they're secure. If they're not secure, you're going to have a fan blade fly off, destroy your fan shroud, and damage potentially other fan blades, damage fill, knock the drive shaft off. You know, there's many different things that can happen. So you want to make sure that you're checking the fan blade clips on the hub. You want to make sure your hub looks good. You want to make sure, again, just make sure you check. Don't just sign off on something just because you want to get through with it. As you can see in this picture, you have a fan blade that broke off, or fan blades that broke off, and they're sitting within that fan shroud. It can happen. It can happen. It's important that you maintain a good annual check on the blades themselves and on the hub. As it says here, if any part of the fan blade is soft or brittle, that means it's time to replace it. That just means it's time to replace it. If you find any with holes, again, that just means you need to replace it. We don't recommend recoating your fan blades. I'll never say to a customer, hey, you need to recoat it, because essentially then your balance between each fan blade may be off, which means that you're going to cause excessive vibration, and again, that can lead to damage later on. Any cracks in the fan blade are potentially serious. That is something that you can kind of let go a little bit until you see 3-inch long cracks or more. That means you need to replace your fan blade, because again, it can break off like you see here in the picture and cause irreparable damage that you're going to have to pay for that could have been avoided. If there are any splits in the trailing edge of the hold on, let me go back. If there are any splits in the trailing edge of the fan blade that goes completely through, it's time to replace it. The structural integrity of that fan blade is gone. So whatever you have to do, let them know, hey, you're in an unsafe situation with the blade itself, and just tell them, hey, we need to purchase one fan blade. It's easy. You should keep fan blades in stock, on hand, ready to repair. I would say at least a full assembly's worth, because with 2 towers, hey, you may need to replace 3 on one, 6 on another over time. If you wait until you need to purchase fan blades and you're in an emergency situation, the lead time on those fan blades are going to be long. You're looking at possibly during peak season, somewhere around 8 weeks, potentially more, because there's many power plants that are in emergency situations. So you want to make sure, if you can, have fan blades on hand, a full assembly, a hub, all the fan blades you need. I would say really look at your spare parts list that was provided to you and say, hey, we need to get these things in store on the shelf, ready for an emergency situation, so that you're not in a time crunch to where, hey, we need to purchase this, procure this from someone, and it's going to cost extra to get it expedited to the site. In your system, your fan assembly has 11 blades. If you lose any of those blades, you cannot run this fan. It's going to be off balance. You're going to cause excessive vibration. You're not going to be pulling the air that you need for your cold water or your hot water to be cooled. So the cooling range is going to decrease. It's just, you're compounding problems. 11 blades need to be installed on each fan. There's not a lot I can say about that. If you want to try taking out every other fan to see if you're going to perform as good as well as the tower is designed for, it's not going to be possible. You want to make sure that you have all the fans, all 11 fan blades that you have on this fan assembly installed correctly and maintained properly. So it's just checking on them every year. They're gonna last anywhere, I would say, between you can say 5 to 15, depending on the blade and how well you're taking care of it, how well you're taking care of your drift eliminators, so on and so forth, the weather in the area. There's a lot of factors that could, cause a fan blade to deteriorate prematurely. So you want to make sure that, again, you have a good maintenance schedule and you're just checking on all your components, all your moving components. Your gearbox and couplings, obviously they're important. They wear. Your gearbox needs to have regular oil level checks, and you can just verify that by the sight glass, which means that when your fan is offline and locked out, you're going to go within your fan stack and you're going to visually look at the sight glass and say, hey, it's above that halfway mark, or imaginary halfway line on the sight glass, and see if you need to add oil or it's fine. And then you're going to go outside the tower, and you're also going to make sure that the oil level indicator outside the tower reads that it's either full or it's in between that need to add oil and full level marks. You're also going to verify that the alignment between your gearbox and your motor, which is going to be your drive shaft, is correct. You don't want things to be off because, again, it's going to cause excessive vibration. If you need to adjust anything, that's the time to do it, because if you put it back in operation and you did not adjust it, you're going to cause your drive shaft to possibly snap, and then you're going to be in another emergency situation to where you're going to need the material either on hand or you're going to need to procure it. And drive shafts are a little less of a long lead time. I would say you're looking at 2 to 4 weeks for a drive shaft, depending on which time of year that you're in that situation. You want to check your bolting. You want to check the backlash. You want to make sure your gearbox is secure to the mechanical support structure. You want to check your support structure as well to make sure that it's not brittle. The bolting is tight, because again, things are moving. There's vibration happening, and that causes micro adjustments within the structure, even though you can't see it. So you want to make sure, as time goes on, every time you come offline, you're just doing those visual hand checks. You're checking your alignments, you're checking your oil levels, and making sure things aren't worn out or you see excessive wear on your gearbox or your couplings or your flex elements that's connected from the coupling to the drive shaft. You want to make sure that's good and tight as well. So this is specific to your tower, your inspection and maintenance schedule. And let's just go down it since it's here. Your general inspection and condition of your tower. It says monthly and semi-annually. If you're walking down the tower, you're going to check on it. You're going to look at your fill. You're going to look at your drift eliminators. And these things, they don't have to be when your tower is offline. This is something that you can just visually look at while the tower is in operation. Hey, I see some damage. Maybe some splash fill fell, visual indicator. You open the hatch, you look inside, or oh no, this is cross flow. So you're going to have to actually be offline to go inside. Well, you just want to make sure that you can visually see. You go on top of the fan deck of the tower. You want to make sure that your fan deck isn't peeling up. Screws aren't just laying on top of the fan deck. You want to look at your fan shroud. Make sure you don't see any chips or light through the fan shroud, because that's indicating that the fan blades are chipping or cutting a groove into your fan shroud. You're gonna check your ladders. You're gonna check your fan motor. This is on a monthly basis, by the way. For your gear, you're just gonna check to see if there's oil outside of the fan stack where you have your oil drain line. Is it spilling out? You're gonna check your oil level. You're gonna check for water and sludge. And you can see that typically it's just going to indicate what does the oil look like in that sight glass. You want to make sure that the cap that's on that oil level indicator outside of your fan shroud is on. It's loose, but it's still, you know, tight enough to where water is not going to seep into it. Let's see here. You're going to check for oil leaks in the hoses and the fittings. That's a visual thing. There's a sight glass on the fan shroud itself that you can visually see your gearbox while the fan is in operation. So you don't have to actually go into the fan stack to check on your gearbox. If you see anything indicating that, hey, we need to shut it down and go inside, that's when you're going to have the opportunity to tighten things down as the tower is off, just to make sure that you're performing the checks that you could be performing later on down the road. If you have the opportunity, do it then. Okay, semi-annually, you want to make sure that, again, you're checking your distribution system. And this is really with the hot water basin. You want to make sure that there's nothing clogging your nozzles, because that's where the water is draining from. You want to make sure that you have even water distribution across your hot water box so that you're not getting any dry spots in your fill, because I go back to this all the time. It's impacting your ability to cool the water. If you need to, if you haven't done it already, you change your oil on your gearbox semi-annually. It's twice a year, every 6 months. Again, treat this like your car. You wouldn't drive your car all year and then change it when you feel like it. If you want your gearbox to seize up on you, by all means. But you want to make sure that you maintain a gearbox maintenance plan. And we recommend every 6 months just to change the oil on it. It's not really difficult. I've seen gearbox after gearbox fail because the maintenance plans have been lax and people don't want to change it, and then it causes them to repeatedly buy gearboxes. Verify the vent. Again, verify the vent is open on your oil level indicator outside of your gearbox. That's going to be that cap that's on top of it. You want to make sure it's secure, but it's not tight. It's not snug tight to allow air to help equalize within that tube so that you can read the oil level properly. You're going to check the alignment, and this is semi-annually. You're going to check the alignment on your drive shaft between the motor and the gearbox. You're going to check alignment for the coupling. You're going to make sure your couplings are good because they wear down as well. Check your flex elements as well. Your fan blades, you're going to spin your fan blades to make sure that they're not rubbing up against the fan shroud clockwise. Make sure you spin your fan assembly clockwise, always clockwise. But you're going to make sure, again, you're going to pick a spot on the fan shroud, and you're going to make sure as you spin the fan blades that each fan blade is hitting that same spot. Yep. Motor. You're going to make sure that the motor is properly greased, it's been serviced. You're going to check the tightness of your bolting. For your structure, you're going to do a visual. If you can get inside the basin when it's, I don't know how often you're going to drain the basin, but I say at least drain it once a year to clean out any debris that's on the bottom of your basin. But whenever you can get inside of your basin, you're going to make sure that you're going to test for tightness on all of your bolting. If it's an eye check it for, I would say, maybe once, and then annually, just give it a good touch, throughout the structure. On the bottom, whenever you drain it, just to make sure that, again, your bolting isn't backing out on you, and it can cause an issue later on down the road. But for the most part, this is a visual check for your structure. You want to make sure you go through and say, hey, it's looking all good, no issues there. And annually, it's the same thing. You want to make sure you go through your entire cooling tower, your distribution system, your hot water basin. You want to check your laterals. You want to check, it's not laterals. You want to check your valves. You want to check your fan deck, make sure it's looking good. You want to make sure your fan deck isn't having excessive wear in a certain area. You want to go through and check your fan assembly. You want to check your gearbox. You want to check your drive shaft, the flex elements, the couplings. You want to check your motor. You want to check your handrail, your guardrail on top of the tower. You want to check your stair tower. It's going through the tower, and each component you are making sure you're touching and then verifying that it's good to go. Making sure that all your moving parts have been serviced properly, and that it's topped off for your gearbox, that the oil level is topped off, and what else? That you're not seeing any broken fill or drift eliminators that's sitting in the bottom of your water basin. Sitting in the bottom of your basin, because that's indicating that something happened, that you need to get in there, possibly replace a little bit of fill. There could be another major issue. Maybe there's a nozzle that broke in your hot water basin that caused a surge of water to come down and damage the fill. So you want to be performing these checks annually, if not semi-annually, when your tower is offline. All right, that concludes this PowerPoint. I appreciate you guys sticking with me through this. I know it was a little tough. So now let's get out to the tower. Let's do a walk down and see some of the things that we were mentioning in the slide. All right, my name is Jonathan Rowe, Southeast Business Development Manager for Evaptech. We're out here on the east side of the cooling tower, and we're going to be doing a visual inspection of the louvers, the bracing for your louvers, as well as looking at the fill, making sure that you don't see any splash bar fill that's angled downward or missing. She had good coverage across the entire width of the cooling tower, as well as all your hardware that you can see from outside of the cooling tower. So we want to make sure for the hardware, you want to make sure for each of your bolting, you're going to have 3 threads exposed, at least 3 threads on your hardware exposed. Your bracing, you want to make sure that there's no excessive bending in this bracing, as well as, can you see it? Okay. Looking at the louver itself, making sure there's no defects, cracks, or missing louvers. And they should have a good overlap so where you're not seeing air gaps. You also want to make sure that when you're looking at your louvers, the support system for the louvers down here is secure. Yeah. That means you have your fasteners all the way through. Again, 3 threads are exposed. At least 3 threads are exposed. And the bracing itself isn't bit, otherwise deformed. And the same thing goes for the FRP. that's supporting your louvers. And again, as I'm down here, when you're performing your monthly, semi-annual checks or your annual checks, visually look at the fill. If you have a good, and you can get eye level with the fill to make sure that you don't see any fill hanging down. So as you're eye level with your splash bar fill, move around just to see if you can see any fill that's hanging, sagging, broken off, because that's an indicator that maybe you need to replace a couple of pieces of fill, or if you're not seeing any issues with your cold water, it's a possibility that you can let it go for longer. But there's a very high likelihood that as that fill breaks off, it's going to end up in your distribution system. So if you see it, catch it, make sure that you repair if needed. And what I'm gonna do is just
Much life is there I want with it.
your chemical system. You can look at your chemical system as you're here, visually check that there's no excessive leaks going on at any of your T's, or your valves aren't leaking. So to make sure that the basin is getting all of the chemicals that's needed. If you do see anything like that, make sure you note it and you let your maintenance team know.
Let's
So I'm gonna do my visual checks. Oh wow. So you guys have an FM approved tower. On the inside, I can see here, and this is why it's important to do your visual checks. You can see in there that there is splash bar that's already sagging.
right in the front.
It's like in between these two.
Oh, I can't just back in that opening.
Is it too dark?
Yes, you look right.
Hold on, maybe I have a light.
I have a light here. Yeah.
Where are you?
Geez, Louise, they're in joke. It's so short, my battery it's sagging, but it's so far back.
Oh yeah, and it's daylight too.
Can you hold light on these? And this all make them shit like see those. What's fair? Store open. Show time at second with our set. See, they catch us first. I really can't see it.
You can't? Okay. Okay. So whenever you see, put it back up. Whenever you see sagging fill, that does not mean you need to replace it. It's just an area to note, because as time goes on, it can degrade. That can be a failure area, you know, a point of failure. Yeah, that's for this area. So you guys ready to move to the okay, it's on me.
Oh, it's all you, man.
All right. So now
How would you change that? How would you
that
back there?
essentially they would have to remove. You're going to go through your drift eliminators, and then you're going to work your way inward.
Question was,
I'm sorry?
I don't know what the question was.
Oh, okay. So how you would end up replacing any areas that are missing or broken or sagging, you would go in through the plenum, through the access doors that's on either side. So you go in that specific cell, you're going to go in, pinpoint the area that you see the sagging splash bar. You're going to remove your drift eliminators, and then you're going to work your way in by removing each splash bar until you find the area that's missing, broken, or sagging, and then you correct that area, and then you replace the splash bar on your way out, and then you put your drift eliminators back in place.
Right.
So that's how you're going to fix that. So now let's move to the stair tower that's located on the north side of your tower. So we're on the north side of the tower. First, what we're going to do is go in through the access door. We're calling it cell 1, right? We're going to go in through the access door for cell 1. We're going to inspect your walkways. We're going to inspect your guardrails, make sure that they're secure, make sure that the hardware is secure. We're going to look at your drift eliminators, make sure they're all in place, and the support for your drift eliminators, make sure they're in place. Then we're going to come back out. We're going to look at your stair tower, and we're going to make sure the bolting, again, the hardware is secure, the steps are actually secured, your handrails, your guardrails are properly secured, and then we're going to check the measurements on them as we work our way up to the top of the fan deck. We're here at the access door on the north side of the tower for cell 1. For the access door, you want to give it the same treatment that you do with all things that are secured to this tower. You want to look at the hardware, make sure that it's properly secured in place. The door itself, you want to check the hinges. Okay, you also want to check the latch and make sure the latch properly rests. Well, sometimes I forget the terminology for these things, but you want to make sure that the latch latches. It's nice and snug. To open the door, what you're going to do is you're just going to push up. It's like a little up and in until you hear that click. It should be that snug, because you don't want it flapping like that. If you get flapping, if you get something where you can tell that it's not properly secured, that just means it's time to replace the latch. But you want to make sure that you push it up, you get that click, make sure it's clear of the end of this latch. Pull it open. You want to check the inside of your door handle. Make sure your fasteners are secure here. Again, always Always 3 threads of exposure. Check the inside of your door for any defects. Make sure. Make sure there's nothing that jumps out at you that's going to prevent the door from closing properly with a good seal.
You can't get locked out of that, can you?
No, you can't. That's why I have this. Watch your step. That's why I have this on the inside. Okay, now to get inside, I'm going to pull it back. Just a smidge, yeah. To get inside, we're going to use this ladder. Make sure you have good 3 points of contact with ladders at all times. So now we're inside of cell 1 on the north side. You want to make sure as you're crawling into this door that you're going to watch your head. This door is probably 4.5 feet and 4.5 feet tall. So you want to watch your head as you're actually entering into the cell. Upon entering into the cell, again, you're looking at your structure. Let me back that up. Make sure that this this fan deck walkway through the center of the tower is properly secure. That means there's even spacing for all of your fasteners going all the way down the walkway on both sides, all around the perimeter of the walkway in this plenum. You also then work your way, we're going to work our way up. We're going to look at the toe boards. Make sure that they're secure. Making sure that your toe boards are secure to each structural member. And then you're going to work your way looking at your guardrail and your handrail, making sure that they're secure and bolted in. Now we're going to look at our columns, your diagonal bracing. As well as your C channels, your girts. And this is the eyeball check for your structural members, making sure that the bolting is in place and secure. This part usually takes, so this part is a very lengthy process. You want to take your time whenever you're performing these checks because you can easily miss 10, 20 bolts, 30 bolts. Okay, so now that we've walked through the cell, we've looked at the structure, what we want to do next is look at your drift eliminators. You want to make sure that there's no gaps in between sheets. Your sheets should be about 1 foot in length, or width, 1 foot in width, and that there's no air gaps in between. They fit snugly together. And you're going to check that from the bottom, where they sit within their support structure, all the way to the top. And this is relatively an easy check to perform whenever you're inside the plenum, because an air gap between drift eliminators is very noticeable. You're going to see light. You're possibly going to see splash fill, your splash fill that's on the other side of this. So this is a relatively easy check to perform. Next, when you're checking your drift eliminators, you want to make sure that each of the sills for your drift eliminators are in place and properly sealed so that there's no air gaps where water is being pulled through your splash fill, through the drift eliminators, and escaping inside of the plenum. So that's why you have these foam pads inside of your C channel as well, to prevent water seeping into the plenum. And the reason why this is important is because water droplets, whenever your tower is in operation, whenever the span is spinning, becomes little BBs. They turn into projectiles and they will damage your fan blades. So you want to make sure that you decrease the water access into the plenum. So now you just walk the length of each side and make sure you perform a thorough check to make sure that there are no air gaps in your drift eliminators. What?
How do you visually check way up there?
Whenever you open up the access door. Oh. So from the bottom of your plenum, whenever you're walking, you can only see the top of your drift eliminators. Once you are on top of the fan deck, you can go through your access door on your fan shroud and visually see your drift eliminators from there. That is a check you can perform even when you're looking at your gearbox and you're walking onto your removable walkway that you've put in place. Look down, check your drift eliminators while you're up top. And you're gonna do this on both sides. Remember, slow is smooth and smooth is fast. Okay. So now that we've performed our visual check on the drift eliminators, we want to check your wind wall that separates, or your partition wall that separates cell 1 from cell 2. Same as any casing that's outside the tower, you want to make sure that the fasteners are in place and properly secured and spaced evenly. You also want to make sure that your access door that goes from cell 1, that's in between cell 1 and cell 2, on the partition wall is properly secure as well. You're going to check your latch. Make sure that it functions well. You're going to check the inside of the door frame. Make sure that there's nothing that prevents you from closing the door and then properly getting a good seal, or properly sealing. You're going to check the inside of your handle. So when you cross over from cell 1 to cell 2, remember your door frame is shorter than the typical size or height for men and women. So you want to watch your head whenever you're walking through. You're going to check for all the fasteners. It's a repeat of cell 1. You're going to check your walkways along each of the toe boards. Make sure they're fastened in place or secured in place. You're going to check your guardrail and your handrail. Make sure that they're fastened, tightened down, bolted down to the columns. And you're going to check your support structure. You're also going to check your drift eliminators for any air gaps. You're going to check the seals for any air gaps. And you're going to check that the foam inserts are glued in place as well. Point to it. And these are your foam inserts. And again, they prevent air, which in turn carries the water, from seeping into or getting into your air plenum and the water becoming projectiles that will damage your fan. So we've just checked cell 2. On the south end of the tower is another access door. This access door is for cell 2. From the outside, you can get into cell 2 if you just wanted to look at cell 2 and not cross over from cell 1 into cell 2. or vice versa, you wanted to check cell 2 before you checked cell 1. So each cell has an independent access door, as well as having an access door on your partition wall. Okay, so we just finished wrapping up looking at the inside of the cells, each cell 1 and 2. And now we're gonna walk up the stair tower. So when you first get to the stair tower, on each landing, you should have a light. You wanna make sure that the cover to the light, isn't cracked. You wanna make sure there's no exposed wiring, and you want to make sure that it's secure to the tower structure. As you're walking up the tower, you also want to make sure that each fastener bolting that you see, you don't see exposed threads. It's not backed out or anything like that. For your rail system, your handrail and your top rail, it was checked. I checked it. It is OSHA compliant. The spacing between each step to your handrail is going to be about 38 inches. To the top rail, it's going to be about 42 inches. And the spacing between this mid rail and your handrail is going to be around 17 inches. So that's all OSHA compliant. All your bolting, you want to make sure you have those exposed threads just to make sure that it's not sitting on the edge. Your nuts aren't sitting on the edge, so over time that it won't back itself out. For each of your steps, you want to make sure that they're bolted in place and that there's no cracks or rips, tears that you can see in each step as you're walking up the stair tower. So as you're walking up the tower, you just want to make sure that you eye everything, even the landings. You want to make sure that they're screwed in place. All the fasteners are spaced out equally. All the bolting, again, is secured properly. That nothing is, you don't see any exposed bolts or fasteners. You don't see thread exposed. Again, each landing has their own light. Visually check that there aren't any cracks, missing bolting in your lighting, and that it's secured properly. And it doesn't hurt to give things a good shake every now and again as you're walking up. On each of the steps over time, even the landings, you're gonna see a textured surface. Over time, this textured surface is gonna wear down. If it becomes slick, or you see that it has a good reflection to it, it may be time to replace it. Another big thing you want to do, maintain good housekeeping. If you see anything that's on the walkway that you can trip over, that could injure you or one of your fellow co-workers, you want to just make sure that you pick it up and put it in a proper area for disposal, or put any equipment that you have lying around the way. Question, are they going to end up grabbing this up? Okay. I'm going to put this.
They clean up after themselves at night. It just takes them a while
Okay.
to get it.
But I like that. It's real world. It's real world, man. Yeah.
So we're now at the top.
Okay. So now we're on the top of the cooling tower, on top of the fan deck, standing on top of the fan deck. Like I mentioned, it has a textured surface. And so as you do a visual check, as we're going to walk around, you want to make sure that, similar to the stair tower, there is a textured surface and you don't have a high reflective area to your fan deck. Also, your guardrail. You want to make sure your guardrail is secure. You want to make sure the bolting is tight. Give it a good tug. Touch your bolting. Make sure you can't spin it. Toe boards are secure in place. Mention this too. You also want to go around to each of your lights. Make sure that your lighting is secure. You don't have loose screws. The lamps on the lights, you want to make sure that the glass or the covers for your lamps aren't cracked or missing any hardware or fasteners. Let's see what they're saying. It was shaking. You just walk each of the tower, or walk the full length of the tower, just checking. This is the access door that goes down into the hot water basin. Oh, I didn't know we wanted to get to that yet, but let's do it. This is your access ladder down into your basin, along with the hatch, access hatch to your hot water basin. You want to make sure the hinges are secure on these access hatches. When you open it up, nothing is impinging or anything like that. It moves freely back and forth, and you want to make sure that there's a little bit of give here, but as you can see, these nuts are backed up all the way to the end of the threads. So you don't want to have threads exposed on the top of each nut. won't go over there. Okay. With your motor, what you're checking on is just making sure that it's properly terminated. You have your conduit going. Yeah.
Not quite finished yet.
Yeah, okay. You have your conduit, you have your box. Make sure that there's no exposed wire. Everything is properly capped off, hooked up correctly. Let's see here. Yeah, that's on the opposite side.
What's the box down at the bottom?
That's your vibration switch. So down here on the bottom, you have your vibration switch. There's going to be connection for it. It's going to be wired up, and you want to just make sure that the cap is still on. It's secure in place. It's not wiggling around or anything like that. And if you need to reset this, make sure you have someone properly trained to come and set this vibration control switch. Qualified, trained professional. You want to make sure that your mechanical support system is properly secured through the fan deck, and it's going to be actually secured under the fan deck to the support structure of the fan deck. So you just want to make sure that the bolting isn't loose. All right, so coming over here, this is the oil level indicator that's outside of your fan shroud. This oil level indicator has been adjusted to properly read full and where you need to add oil. The cap should be hand tight. There, it feels snug. Back it off just a little bit. That allows air to enter into this tube to properly show you or indicate the oil level. You want to make sure this needs to be open. Goes along with the length of the pipe. If it's turned, come on, you.
Unlock it.
If it's turned like that, it's closed.
Control locking mechanism.
This locks it from turning. So you want to unlock it, close it off, open it up. This is where you drain the oil from the system. So during operation, this is capped off and this is open so you can properly read the oil level. If you were changing the oil, cap this off or take the cap off, you open it up, it's still open, or you close it and then you open it up, you're draining your oil. Here is a sight glass that can be removed on your fan shroud. And this is where you're going to actually look into to see the gearbox whenever the fan is in operation. But when the fan is in operation, this is in place. You only take this off when the system is shut down and locked out. And you're doing visual checks inside, but you don't want to remove your access door to gain access. So, again, if you're looking at your fans, your gearbox, your drive shaft, this sight glass is used for that purpose. I could clean it.
Access door.
So to gain access inside the stack, there's bolting all along the perimeter of this access door. You remove the bolting, preferably with 2 people. You can remove this access door, set it to the side, and then you would grab your grading platform for your removable walkway, so that you can walk out into the cell to check your fans, to check your gearbox, to check your fan hubs, to check your drive shaft connection to your gearbox, and perform your monthly or semi-annually checks on your cooling tower, or your annual checks on your cooling tower. Down to the bottom a little bit. Yeah. Textured surface should be on top. That's your walking area. The other side of the grating is smooth. This should be on the bottom. You want to walk on your textured surface. You're going to stand outside of the fan stack, lay your grating down, and slide it in. Make sure there's some overlap. The way this is orientated, texture side surface up, and you can see that on each of the texture surface pieces, there's some cross bracing that goes all the way through. That, if you try to lay it down the other way, it's not going to fit. It's not going to fit properly. That should be the first indicator to you that you need to reorientate your removable walkway pieces. I've got the your grating. You want to make sure that the grating is orientated properly, so that one, it fits in place properly, you're not damaging any of the support for your grating, and that it just sets inside and fits like it's supposed to. But you want to make sure you have some overlap, because there's a space in between your fan deck and the structural member for your walkway. You want to make sure that you have the grating to cover that space. And so I'm overlapping it, or I'm ensuring that the grating extends from the support structure to the fan deck. Blah, 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 blah. All right, I'm gonna walk in. Without moving to the edge, you want to be in the center of each of the grating pieces that you put down. So that there's proper balance. Now before I put this last piece in, I'm gonna place this on the edge and it should fit properly. If it doesn't, that means I may have to adjust the pieces that I already put in. It may have to be backed out a little bit outside. This may have to come out a little bit. And then each piece corresponding may have to slide back. But you have to make that determination once you get to the end. Good to go. So, once you're inside the fan stack, you have your walkway laid in. You're going to come up to your gearbox. What you want to check is the sight glass on this gearbox. You're going to check the oil level. It has to be halfway or above. As you can see on this sight glass, make your imaginary line that goes through the center point of the sight glass to verify that the oil level within the gearbox is adequate and full. Next, you're going to look at this drain line. You're going to make sure that it's not leaking, that you don't see any visible leaks happening. And also, you're going to ensure that this valve here is open. The way you know it's open, it's in line with your piping, with your tubing. That's indicating to me that this line is open. If it was closed, you wouldn't get a proper read on your oil level indicator outside of your fan shroud. Okay. Next, while you're here, you're going to look at your flex elements and your coupling. You're going to make sure that they're all properly in place and fastened tightly. And you're going to give it a spin. You want to make sure that nothing's impeding or stopping it from being able to spin properly. And while you're on the platform, a good way to know where to spin or how to spin it is away from you. Do not spin it towards you. That way the fan is going to move clockwise. You also want to look at your torque tube and the guards. Your torque tube should be secured to the structure of the your torque tube should be secured to the structure of the tower. So you have your bolts here, here, on each side. Make sure you cannot spin them. A good hand check should be good enough. Make sure your guards are in place and that they're secure. It's these, and you're going to have two. One here, and one on the other side of the drive shaft. You're also going to look at your fan hub and make sure that all the bolts are in place for each of your fan blades, because this is securing each fan blade to the hub. Yeah, I gotta spin it. Give me a little watch. Yeah. While you're spinning it, you're looking for cracks, missing bolts, strip bolts, anything of importance or something of concern that would indicate that you may need to either replace it or have someone come take a more in-depth look at the condition of your fan hub. So now we're going to spin the fan, and we're going to make sure that we're going to pick a spot on the fan shroud, and we're going to spin the fan. Each blade should pass over that spot at an equal distance, give or take less than, let's say, 1/8 of an inch. It shouldn't be much. Remember, you're eyeballing it, so it's not going to be spot on, but you shouldn't see a huge deviation. And you're always spinning your fan clockwise, to the right. No, that's to the left. Well, yeah. All right. See, and now I have to go in there to pull them out. Huh? Once you do that, you go in reverse order, remove the grating as you walk yourself out. Remove one grating piece at a time. Great time to mention, you shouldn't be up here by yourself. You should always have a hole watch. We call it the buddy system. You should always have someone with you whenever you're working on your cooling tower to make sure if something happens, you have someone that could help seek assistance, help remove the doors, help fasten things back in its proper place. Once you have your door back in place, put all your bolts back into the access door. Make sure you tighten them down. The first bolts I would tighten down is going to be your access door to your fan deck, just to make sure that you have it in the correct place so that it's not going to be difficult for those bolts to go in. Don't want to strip it. Do not over torque the bolts. You want to move to your top bolts. So now we're going to look at the ladder system. You want to make sure that this guard is here in place so it's secure and snug. It's not loose or flap in the wind. And that you have your fall arrest system here. When you're on the bottom, you can pull it to make sure that it's, fully capable of extending all the way to the bottom. You want to make sure that you have your rope properly secured onto it so that when you're on the bottom, it can be pulled. You also want to make sure that you want to make sure that your clasp and latch properly works, and that if you just push in on it, it doesn't open. But if you push down on the release, that opens. So that's secure. And that your bolting is in place and secure to the tower all the way down. So now that forgot to do one thing. Check the fan shroud. So before we go down under the fan deck, we're going to check around the entire fan shroud to ensure that all the bolting is secure. Here, the bolting is still being placed on the door, the access door to the fan shroud, but the remaining bolts should be properly secure. And you want to walk completely around the fan shroud. You're going to check the fan shroud for cracks, any visible signs of cracks, holes. There should be no visible light through the fan shroud. One thing to note, you should always have a cover where your drive shaft, over the coupling between your drive shaft and the motor. So under this cover, you're going to see the coupling, a flex element, and then the end of the drive shaft. But this should be in place and secure. So now that we've walked the top of the tower, we've seen inside the fan stack, we've walked around it, we're going to go under the fan deck and we're going to check the hot water basin. We're going to check nozzles, and we're going to check the distribution system to make sure that everything is in good working order and in its place. So the first thing you want to look at whenever you open your access door is your ladder. The ladder should be secure. It shouldn't have a lot of give to it. It's going to have some, but not a lot. You want to make sure you're bolting. You want to make sure your bolting is properly tightened with some thread exposed. Okay, now that we're under the fan deck, on cross flow cooling towers, they have what we call hot water basins, meaning your header's coming into your tower and it's pumping water out of these outlets or flanges that's connected to essentially a system that is going to help disperse the water into the splash box, which is just going to feed the water into the basin. What you want to do, this is not to be opened. You don't want to just open this. It's fine. If it was missing, cracked, dented, spewing water out, you know, to the fan deck, then that's something to note. But if it's in place, it's secure, it's fine. You want to look at your header. You want to make sure there's no visible wear. These are FRP headers, meaning over time they can wear down and you can start seeing fiberglass, little threads of fiberglass, but they're wrapped. So as long as you don't see any visible signs of water leaking out of the header, it's good to go. So as you walk around within this basin, each of these black circles are nozzles. You want to make sure, one, that the nozzles are in place and that there's nothing plugging the nozzles. Balls or debris that could affect the waterfall pattern that is helping to cool the water. Oh, saddles. Under the header, what you also want to look at are the saddles. When the system is on, there's a lot of pressure put on these headers and there may be some flexing and movement. These saddles help the header stay in place. So you want to make sure that you want to make sure that the header is secure. There's not a lot of flex in it, or that the shape that it's cut out isn't deformed. It should have a good, almost spherical shape that matches your header. Now I'm going around the entire water basin, hot water basin, and ensuring that all of the nozzles are in place. And we don't have any missing nozzles or cracked nozzles. And under the deck, you can transition from one cell to the next. So now I'm going over into cell 2. And performing the same checks. You want to check that all of your basin nozzles are in place. Nothing looks deformed or not properly seated into the basin. If you find any debris that you can remove while you're down here, this is the time to do it while the system is off. Because debris, sooner or later, will clog your system and cause issues. And again, on each of your headers, you want to check the saddles. Make sure your saddles are snug tight, all the bolting's in place, there's no give to them, so that whenever this header flexes, it moves, the saddle will keep it in place. You can also check the ladder. If you don't want to go up top and walk down each ladder while you're under the deck, you can move between cells. Make sure you're checking the ladders to make sure that they're secure. Also note, you want to make sure that your structure, one, your support structure for your fan deck is in place, and that you don't see any visible signs of wear for the support structure for your fan deck, which are these C channels directly into your fan deck. As well as your girts. You want to check your girt and the hardware that your girts have to make sure that they're tight and that they have proper thread exposure. You're going to check your diagonals as well. And you're going to check your columns. We've just wrapped up walking down the tower. We've went from the inside classroom portion where we went over the PowerPoint slide where you had the overview of what we're going to be expecting on the tower. We've crawled or we've looked throughout the outside around the tower. We've examined the louvers, the support structure for the louvers. Then we went inside. We looked at the access door to get inside of the plenum. We've looked through cell 1. We've looked at cell 2 on the bottom of the tower. We've looked at the stair tower. We've also looked at the fan deck, the guardrail system, the lighting system. We've also looked at the fan shroud, the motor. We've looked at the drive shaft, flex elements, couplings, torque tubes, the gearbox, and the fan assembly. We've also crawled under the deck to look at your hot water basin and the nozzles that are inserted into the hot water basin. We looked at the header saddles, and the support structure. We've also looked at the ladder system and the fall arrest system for the ladder. This is going to conclude the training for your tower, and I'm going to finish up by crawling through cell number 2 on top of the deck just to make sure that it's an exact replica of cell number 1. My name is Jonathan Rowe, Southeast Business Development Manager for Evaptech, and I appreciate your patience, and I look forward to working with you in the future.